Let's solve GATE CS 2007 question. Define the connective star for Boolean variable x comma y as. So this definition is given to you. A new connective has been defined. A new definition has been given to you. The question is saying that this operation star you have and x star y that is equal to x and y or x bar and y bar. Okay. And let z equal to x star y. Consider the following expressions p, q, r. This is p, this is q, this is r. The question is asking which of the following is true. P, Q, R, which of them is valid, which of them is true. So first of all, you look at this new connective that has been defined, new operation that has been defined. So you can see the question is saying that x star y, this star operation has been defined, and the question is saying that x star y is equal to xy or x bar y bar. So this is the new definition that is given to you. This is the new operation that is given to you. But if you look at this operation, this is your exclusive NOR operation. We already know that this is XNOR operation. Yes or no? X XNOR y that is equal to xy or x bar y bar. This is the standard equation for exclusive NOR. So actually this star operation that is same as what? That is same as your XNOR operation. Okay, very simple. This is the first thing that you should notice, because this is the standard equation for XNOR. We already know two equations. One is for XOR, x XOR y that is actually equal to x bar y or x y bar. And what is XNOR? That is x bar y bar or xy. Okay, so these are the two equations. These are standard equations for XOR and XNOR. This is XOR, this is XNOR. Very simple. Now let's see the next thing. Let me tell you that XNOR and XOR operations, these are commutative and associative. So before we further solve this question, let me tell you that this XNOR operation, also this XOR operation, they both are commutative as well as associative. What I want to say, commutative means what? Commutative simply means that A XOR B that is same as B XOR A. Okay, similarly, XNOR is also commutative. So A XNOR B, A XNOR B that is same as B XNOR A. Okay, so this is the commutative property. Both are commutative and both are associative. So let me tell you, this is called commutative property. Okay, both of them are associative, both of them are commutative, both of them are associative. Now let's see the associative property also. So associative property is like this, that if you have A XOR B XOR C, if you do first XOR first, or if you do the second XOR first. So remember, if you do the second XOR first, or if you do the first XOR first, then these both are basically same. This is called the associative property. Or in simple words, you can simply write it A XOR B XOR C. Okay, directly you can write. So remember, these three equations, these are basically same. These three expressions, these are basically same. Similarly, XNOR, that is also associative. What it means? XNOR, this is also associative. What that actually means? This simply means that if you have A XNOR B XNOR C, A XNOR B XNOR C, then if you do the first XNOR first or if you do the second XNOR first, both will be basically same. And that is the reason you can in simple words, you can simply write like this: A XNOR B XNOR C. So all these three expressions, they are same. Okay, so XNOR is associative, XOR is associative, XOR XNOR both are commutative also. If you are thinking how to prove it, you might be thinking, so actually you can prove all the results that we have seen. XOR, XNOR, they are associative, they are commutative. If you want to prove, you can easily prove using the truth table. Okay, so for example, let me prove for XNOR. If you want to prove that XNOR is associative, then how to prove that? Okay, so let me do that. So that is actually very simple. Using the truth table, you can easily prove. So let me do this. X XNOR Y. First I will find X XNOR Y. Then with that I will find XNOR Z. Okay, you create the truth table for this. Also you create the truth table for X XNOR. First you do Y XNOR Z, and then you do this first XNOR. Okay, now you what you do, both the truth tables you find. then you will see that these truth tables actually will be same. Okay, let me quickly do only for some of the rows. For example, for this row, let's see what this will become. So first we will do x XNOR y. You know that XNOR will be 1 when x and y both are same. So here x and y both are 0. So this XNOR, this will be 1. 1 XNOR 0, that will be 0. Okay, now let's come to this. So first you find what is y XNOR z. 0 XNOR 0, that is equal to 1, because here both are same, so that will be 1. Then you do XNOR with 0. 1 XNOR 0, that will be 0. So did you notice that they are basically same? Actually this will happen for every row. You can take, for example, this row you can take as homework. Let me take the next row. For this row, you first find x XNOR y. Remember both are different, so XNOR will be 0. Now you do XNOR with z. 0 XNOR 0, that will be equal to 1. Now let's find this. First you do y XNOR z. Y XNOR z, you can see 1 comma 0 XNOR, that will be 0 because both are different, so it will be 0. Now you do XNOR with x. So 0 XNOR 0, that will be equal to 1. Again you can notice both are same. Let's take the next row as homework. This is also your homework, you can take it. Now let me do this one. Okay, for this row you can see x XNOR y, that will be, both are different, right? So both, that will be 0. Now you do XNOR with z. 0 XNOR 1, that will be 0. Okay, now let's see this. Y XNOR z, that will be 0. 0 XNOR x, 0 XNOR 1, that will be 0. Do this homework. Now let me do this one. You can see x XNOR y, that will be 1 because both are same, so it will be 1. XNOR with 1, XNOR with z, that will be 1, so it will be 1. And now y XNOR z, so you can see 1 1, so XNOR will be 1. Then you do XNOR with x, so 1 XNOR 1, that will be 1. Okay, so like this you can actually see that this and this, they will be same. Let me tell you, you can easily see 0 0 1 1. Okay, and the homework also you can do. The point is very simple, that XNOR is associative. I hope you understood. So this is how you can prove all the results that we have seen. XOR, XNOR, both are commutative, both are associative. This you can easily prove using the truth table. Okay, now let's come back to this question. So we have seen that this star operation is nothing but your XNOR operation. This is the first thing that we have found. Also we have found that this XNOR operation is commutative. Also we have found that this operation is associative. What are the meaning? We have already seen associative, also commutative. This meaning we have seen. Now let's see. What is P, what is Q, what is R? First of all, the question is saying that Z is equal to X XNOR Y. Okay, because remember the question is actually saying X star Y, but you know star is same as XNOR. Okay, correct, because question is saying Z equal to X star Y. So that is basically X XNOR Y. Okay, now what is P? Let's look at P, let's look at Q, let's look at R. So what is P? The question is saying that P is this equation, X equal to Y star Z. Okay, this is the P, X equal to Y star Z. Okay, so let's see this RHS. Okay, what is this RHS? Y is there. Okay, this star is XNOR. What is Z? Okay, remember there is Z here. So this Z we already know, that is X XNOR Y. So this Z I will replace with X XNOR Y. Yes or no? This is Z. Z is equal to X XNOR Y. So this Z I will replace with X XNOR Y. Very simple. Now you know that XNOR is commutative. Because XNOR is commutative, so I can also write like this, that this will be XNOR Y XNOR X. So we know that XNOR is associative and commutative. So we can just apply the commutative property. It will become Y XNOR X. And because it is associative also, so we can remove the parenthesis, remember. Okay, just remove the parenthesis. Now you know that Y XNOR Y, that will be same as 1. Okay, because both are same. So basically XNOR is 1 when both are same. So this will be 1. Now finally we got 1 XNOR X, and that will be same as X. And that is your LHS. LHS, RHS both are same. So that is the reason I can say that P is valid. Okay. What is Q? Q is saying Y equal to x star z. Okay, this is q. So remember, q is saying y is equal to x star z. X star z. Okay, so you already know what is star. Star is your XNOR. So basically that is x XNOR z. Okay, now let's see. Basically what this q is saying, that y is equal to x XNOR z. Now you already know what is z. Z is already given to you, that is x XNOR y. So I can put it, z is already given to you, that is x XNOR y. You know that XNOR is associative. So I can write it x XNOR x XNOR y. Okay, because XNOR is associative. Now what is this? Here you can notice both are same. Okay, x XNOR x, both are same. When both are same, then XNOR will be 1. So this will be 1. So I will get 1 XNOR y. This we have already seen. This will be same as y. Why? What is the reason? Reason is very simple. If I put y equal to 0, here 0 will come. If I put y equal to 1, here 1 will come. So you can notice y is coming as it is. Okay. So here you can see that RHS, this RHS has become y. So remember, q is saying that y is equal to y. Yes, that is valid. Okay, that is valid. Now let's see what is R. R is saying x star y star z equal to 1. This is what R is saying. R is saying that x star y star z is equal to 1. Okay, you know what is star. Basically, that is same as star is XNOR. That you already know, XNOR. Okay, so let's do this. X XNOR y XNOR. Already you know what is z. This is given in the question. Z is basically x XNOR y. You know that XNOR, that is associative and commutative. Okay, because it is associative and commutative, I can simply write like this: x XNOR y. Okay, basically it is like this. See, x XNOR y XNOR x XNOR y. This is how I can write it. Okay, I can remove the parenthesis because anyway the XNOR operation is associative, that you already know. So I can remove the parenthesis, and I know because it is commutative also, associative also. So what I can do, I can take these two together, I can take these two together. Okay, so remember, I can do like this, that x XNOR x XNOR XNOR y XNOR y. Okay, is this clear? X XNOR x XNOR y XNOR y. Okay, now you can notice what this will become. This will become 1. You know this will become 1. So you can see here, this actually will become 1 because both are same, x comma x. This also will become 1. So finally what I got? I got 1 XNOR 1, and that is same as 1. So you can see that RHS is also 1. So LHS and RHS both are same. R is saying that 1 is equal to 1. Yes, that is valid. Okay, so that's it. So we have seen that P, Q, R all are valid. So for this question, the answer will be option D. Okay.